All right, geometry 6-3, medians and altitudes of triangles. We're actually just going to be focusing on medians and our centroid theorem for this lesson. So our centroid theorem, okay? So the medians of triangles intersect at a point called a centroid. That is 2/3 the distance from each vertex to the midpoint of the opposite side. All right, so what's that mean in practice? Let's take a look. All right, so using our centroid theorem, we're going to do this a couple times, a couple different ways. So in triangle ABC, P is centroid. Okay, that means L is the median, M is the median, N is the median. It's the middle of the side, but it's not a right angle. All right, so that's why we have different names, and we have to find our lengths differently than we have before. So P is a centroid. Okay. BL equals 6. Okay, BL, the whole thing, BL is 6. Okay, it wants us to find BP, and then it wants us to find PL. All right. So what's it tell us? It says, okay, so the centroid is 2/3 of the distance from each vertex. So from the vertex to the centroid is 2/3. Okay. So centroid, that is 2/3 the distance from each vertex to the midpoint. The opposite. Okay, so from B to P, we are 2/3 of 6. All right. So, and it wants us to find BP and then PL. So we're going to do BP first, okay? So BP is 2/3 of 6, or 6/1. So BP is 12 divided by 3, and that equals 4. So from B to P is 4. Okay. Now P to L. We're going to mathematically do these, all right? So BP plus PL equals 6. Now we know BP is 4 plus PL equals 6. All right, so what's PL? Well, PL equals 2. Okay, so we found from BP, that is 4, and PL, that is 2. All right, let's step it up a little, okay? So we are going to apply our centroid, so we're going to apply our same, 2/3 from vertex, center, 2/3 of the whole thing. So PY is 7, and it wants us to find LP. Okay, so let's see what we've got. Okay, so it doesn't specifically tell us that P is a centroid, but all of these markings prove that it is. Because from vertex, this has to be the midpoint or the median, because these two are congruent. These just aren't 90-degree angles, so that is why we are calling it the centroid. All right. From L to Y, no 90-degree angles, but these two are congruent on this side, centroid. Again, vertex to median, these two are congruent, no 90-degree angles though, all right? Centroid. Centroid. All right. So we're going to find LP, and we know PY. Okay. So LP, well, what do we know about this from here to here is 2/3 from here to here. So it equals 2/3 of LY. All right. Well, we did that up here. But then we knew the entire length from B to L. We do not know the entire length of L to Y. Okay. So let's break this down a little further. So we're still trying to find LP. LP equals 2/3 of, well, what parts make up LY? Well, you got LP plus PY. Okay, now we can substitute in the 7 here. So LP equals 2/3 LP plus 7. Okay. Now let's distribute that 2/3. So LP equals 2/3 LP plus, well, 2 times 7 is 14/3. All right. Well, now let's get our LPs on the same side. So let's subtract 2/3 LP. Let's make this one 3/3 minus 2/3. I made it 3/3 because we had one LP there. That gives you 1/3 LP equals 14/3. Okay. So let's isolate LP. Well, we can't divide by 1/3, but we can multiply by its reciprocal. Multiply by its reciprocal, and that gives me LP equals 14. Okay, because when you multiply and divide by the same number, they cancel each other out, and you're left with 14 over 1, or 14. All right, so on the back, we're going to apply this, okay? So we are going to find the centroid on the coordinate plane. Chimes. Lashaya needs to hang a wind chime with a single piece of cord. The pipes of the wind chime are attached to a triangular platform. When the platform is placed on a coordinate plane, the vertices of the triangle are located at those 3 points. What are the coordinates of the point where the cord should be attached to the platform so the wind chimes stay balanced? Okay, so let's plot these. So 1, 1, we'll call that A. We'll call this B, 11, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5. Call that B. And we're going to call this C, 7, 10. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C. All right. So we've got a triangle base. Alright, so what we're needing to do to find the centroid is we're going to go from each vertices to the median or middle of each side across from it. Well, we have to find the median or midpoint of each of our sides, so we can go from our vertices over to the midpoint precisely. So we know a midpoint formula for points. So let's do A, B first. So let's first find our midpoint of A, B. Now that's going to be your x plus x divided by 2. And then your y's added together divided by 2. And then we see 12 divided by 2 is 6. And 6 divided by 2 is 3. So 1, 2, 3, 4, 5, 6. 1, 2, 3. Alright. Vertices to midpoint. Alright. Let's do our midpoint of AC. Alright. So again, your x's added together, 1 plus 7 divided by 2. And then the y's, 1 plus 10 divided by 2. 8 divided by 2 is 4. 11 divided by 2 is 5.5. Alright. 1, 2, 3, 4. 1, 2, 3, 4, 5.5. Vertices to midpoint. Now please make note, these are not going across and they aren't perpendicular, they aren't making 90-degree angles, which is why we have a new term. Alright, we're doing slightly new math. Well, old math, but in a different way. Midpoint. Let me see, we got AB, we got AC. Now let's do BC. BC. All right, BC. So again, add together your x's, divide by 2. Add together your y's, divide by 2. 18 divided by 2 is 9. 15 divided by 2 is 7.5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7.5. So right here. Alright. So our centroid is where they all cross. Alright, well we can give a good approximate of where these all cross. So we'll call that point P. Let's see approximately where P is located at. So 1, 2, 3, 4, 5, 6, about 6 1/3. And then 1, 2, 3, 4, 5 1/3. Alright. Because it's definitely is less than half. Alright. So let's change these into improper fractions. So that would be 19 thirds approximately and 16 thirds approximately. So that'd be the approximate. And if you were doing on a state test, you could find the approximate location, whether they be mixed fractions or improper fractions, and then see which, by process of elimination, you could pick the centroid. Now, example 4, we are not doing. It is not on our state test. It is outside of our state standards. And so we are actually not going to be doing example 4. So, and actually you don't have any on today's assignment like example 3, but I wanted to throw that out there in case the state wants you to find the centroid from coordinates. I wanted you to have seen that before and be able to do that. But today's assignment, they are based on examples 1 and 2 that does coordinate with our standards and your goals and what the state will test you on. So I want to make sure you know how to do these. Again, it's from what is corresponding with our state standard. All right, your assignment is in McGraw-Hill. Get that done and turned in. Remember, next Friday, the very last day, you can turn in anything for Unit 6, so don't get behind.